Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, hydrogen. Last class I have finished completely redox chapter. Then now I am going to start hydrogen. Hydrogen is the most abundant element in the universe and the third most abundant on the surface of earth or globes. Highest, most abundant element in the universe, hydrogen. That is very important things I am telling you. Hydrogen is the most abundant element in the universe. It is found in maximum and the third most abundant on the surface of the globe. Okay. Hydrogen has the simplest atomic structure among all the elements around us in the nature. In atomic form, it consists of only one proton and one electron. Hydrogen atom has one proton and one electron. However, in elemental form, it exists as a diatomic. It will now, you can't get only H. Always you will find it in the H2 form. Okay. It is not found in atomic form. It is found in molecular form, also called elemental form. It exists as diatomic, means H2, and is also called dihydrogen. Di means two. Two hydrogen means H2. It forms more compound than any other element. It forms maximum compound. It forms more compound than any other element. Okay. And also you should know, global concern related to energy can be overcome to a great extent by the use of hydrogen as a source of energy. It has capacity to give maximum energy. Okay. Means world is thinking for the energy. Then global concern related to energy can be overcome to a great extent by the use of hydrogen as a source of energy. In fact, hydrogen is of the great industrial importance. Okay. Now I am going to tell position of hydrogen in periodic table. Hydrogen is the first element in the periodic table. However, its placement in the periodic table has been a subject of discussion in the past. You know by now that the elements in the periodic table are arranged according to their electronic configuration. Already I have discussed it during periodic table. Okay. Elements in the periodic table are arranged according to their electronic configuration. Hydrogen has electronic configuration 1s1. Means last only one orbit is there, in that only one electron is there. S orbital is there. S orbit or S orbital you can tell. 1s1. On one hand, its electronic configuration is, that is the first, hydrogen has electronic configuration 1s1. Okay, this is the first important thing. On other hand, the electronic configuration is similar to the outer electronic configuration of alkali metal, NS1. Alkali metal electronic configuration is NS1. N means number of orbit. Then alkali metal has electronic configuration N1. It is similar to the alkali metal. It is similar to alkali metal, which belong to the first group of the periodic table. On the other hand, On the other hand, like halogens, it is also similar to hydrogen. With hydrogen, halogen, and halogen has electronic configuration ns2 np5, means total 7 electron. But 8 electron is required to get stability. To get octet, 8 electrons are required, and it has 7 electron, ns2 n5. N is the number of orbit. Then now it requires 1 electron to get stability. And hydrogen also, it has capacity 2, but it has only 1 electron. It also lack 1, and halogen also lack 1. Means both require 1 electron to get stability. Because hydrogen, if they will get 1, then you will get, you can say, helium structure, stable structure you will get. Okay, like inert gas, helium comes under inert gas. Then it is also lacking 1 to get stability. Duet it will get, 2 will be completed, and it will get stability. And here in halogen 7 electrons are there, they want 1. Then hydrogen also want 1 to get stability. Halogen also want 1 to get stability. Hence, in this way, it is similar to the halogens configuration. Okay, halogen belongs to the 17th group of the periodic table, because it is short by 1 electron to the corresponding noble gas configuration. Okay, hydrogen 1s2, helium is 1s2, it wants helium configuration. Okay, that's why it is also lacking 1, and this also, halogen also lacks 1. Hydrogen therefore has a resemblance to alkali metal which lose 1 electron to form unipositive ions, as well as the halogens which gain 1 electron to form uninegative ion. Hydrogen form unipositive, electropositive, and halogen uninegative. Okay, uninegative or unipositive, electronegative and electropositive. Halogen is called electronegative elements and hydrogen electropositive. Like alkali metals, hydrogen forms oxides, halides, and sulfides. Alkali metal means group 1 metals. In general, they form oxides, metal oxide, metal halides, metal sulfides. Hydrogen also forms same way. Like alkali metals, hydrogen forms oxides, halides, and sulfides. However, unlike alkali metals, unlike alkali metal, it has a very high ionization energy, or you can tell enthalpy, very high ionization enthalpy, and does not you can say possesses metallic characteristics under normal conditions. Okay, this hydrogen has not metallic characteristics. Okay, under normal condition. In fact, in terms of ionization enthalpy, hydrogen resembles more with halogens. Okay, in term of ionization enthalpy, hydrogen resembles more with halogen. Delta H, heat of formation, delta H of lithium is 520 kilojoule per mole. Delta H, F, I am doing formation, heat of formation. Then delta H of lithium is 520 kilojoule per mole, and fluorine is 1680 kilojoule per mole. 1680 kilojoule per mole, very high. And Hydrogen is 1312 1312 kilojoule per mole. Okay, like halogen. Okay, like halogen, you can say it forms a diatomic molecule. Halogen also form diatomic like F2, Cl2, Br2, I2. Hydrogen also form H2, similar. Both form I can say molecules, diatomic molecules. And also it combines with elements. It combines with elements to form hydride. Hydrogen combines with elements to form hydride and a large number of covalent compounds. Hydrogen forms a large number of covalent compounds and also form hydride like metal hydride, sodium hydride, potassium hydride, calcium hydride, etc. And also in terms of reactivity, it is very low as compared to halogen. Okay, in terms of reactivity, it is very low as compounds to halogens. Okay, this in comparison to halogen, this will be very low. Hydrogen will react very slowly and less. It is very low as compared to halogen. Halogen is very reactive. Okay, in spite of fact that halogen to a certain extent resembles both with alkali metals and halogen, it differs from them as well. Hydrogen actually, despite similarity with alkali metals and halogen, it differs also. It differs from them as well. Now the pertinent question arises as where should it be placed in the periodic table? In periodic table, where it should be there? It has similarity with alkali metal also, group 1 and group 17. Then where it should be there? Then in periodic table, it got separate place. Okay, on the top. Then this is these things. It was always a matter of discussion. Where should it be placed in the periodic table? Loss of electron from hydrogen atom results in nucleus. You know, only one electron is there. Then that if it will lose that electron, then only one proton, means nucleus, will remain. Loss of the electron from hydrogen atom results in nucleus, means H plus. What we are telling, proton. H plus is called proton because electron is not there, and its size is very small. Roughly I am talking about just approximately 1.5 into 10 to the power minus 3 picometer. This is the size of a proton, means nucleus. Nucleus of hydrogen. Nucleus of, actually every atom has nucleus and their size is different, not the same. Okay. Then for the hydrogen, if electron will go, then what is left out? That is the proton, means H plus. That is also called, you can call nucleus, and its size is approximately 1.5 into 10 to the power minus 3 picometer. 1 picometer means 10 to the power minus 12. 10 to the power minus 12, a meter is called picometer. Then here it is 1.5 into 10 to the power minus 3 picometer size. This is extremely small as compared to normal atomic and ionic size. Okay, generally atomic or ionic size, generally it will be 50 to 200 picometer. Then it is more, that is a 10 to the power minus 3 picometer. This is the 50 to 200 picometer. Generally, it will be there. As a consequence, H plus does not exist freely and is always associated with other atoms or molecules. You will not get H plus freely. Always in a combined state you will get. Thus, it is a unique in behavior and is therefore best placed separately in the periodic table. In periodic table, its place will be separate, not with group 1 and not with these things, group 7, 17th. It is kept separate at the top. Now, I am discussing H2 dihydrogen, means H2 hydrogen molecule, about the H2 hydrogen gas. Okay. Then now this you should know. Do you know more about the hydrogen gas H2, also called dihydrogen? Dihydrogen is the most abundant element in the universe. In the universe, 70% of the total mass of the universe. Now understand how many, you can say, quantity of hydrogen is there. 70% you can say 70% of the total mass of the universe. Means you can tell it is a ruling. Hydrogen is ruling. 70% mass of the total universe is due to hydrogen gas. Very important. 70% of the total mass of the universe, and is the principal element in solar atmosphere. Main element is hydrogen. Okay, in complete solar system, the giant planets like Jupiter is a very big planet, Jupiter, and second is the Saturn, consist mostly of hydrogen. They are made up of Jupiter and Saturn consist of mostly of hydrogen. That they are made mainly from hydrogen and hydrogen only, Jupiter and Saturn. However, due to its light nature, it is much less abundant. Much less means very less, 0.15% by mass in the Earth atmosphere. In Earth's atmosphere, it is very, very less. That is the 0.15% only. Okay, because it is a light gas. Hydrogen is a light gas, and on Earth it is found less, 0.15% by mass. In the Earth's atmosphere it is less. Of course, in the combined form, but in the combined form it is found more. Of course, in the combined form it constitutes 15.54% of the Earth crust. 15.4% in a combined state, but free hydrogen as a hydrogen, that is a less, only 0.5%, 0.15%. But in a combined way, on the Earth crust, it is 15.4% of the Earth crust. And the ocean, it is also present in ocean in a combined way, like water, H2O. Then in one molecule 2 hydrogen is there. Means molecular mass is 18 for water. Then in out of 18, 2 gram is water only. Out of 18 gram, 16 gram water and 2 gram hydrogen. Then it is found on, we can say, on Earth crust and the ocean also. In the combined form, besides in water, it occurs in plant and animals tissue also. In plant also, you know that plant has organic compound like carbohydrate, you know, all the things. Then in carbohydrate, hydrogen is there. in carbohydrate, hydrogen is there. Like that, many organic compounds are present in plant and animals. Then there also it is in the combined forms. It occurs in plant and animals tissues as a carbohydrate, protein, hydrates, including hydrocarbons and many other compounds. All things I told you, carbohydrate, protein, hydride, hydrocarbons and many other compounds. Hydrogen is found. Nothing is there where hydrogen is not there. You think everywhere hydrogen is there. Now I am going to discuss isotopes of hydrogen. Okay, hydrogen has three isotopes. First is protium, 1H1. Second is deuterium, 1H2, also called D, capital D, deuterium. And third one is tritium, 1H3, means 1H1 protium, 1H2 deuterium, and 1H3 tritium. And they differ only in number of neutron. All three isotopes they differ in number of neutron. In protium, protium is the common hydrogen, what we are telling, that is the protium. Always hydrogen we are telling common, that is 1H1 protium. It has no neutron. Generally, in any atom, electron will be there, proton will be there, neutron will be there. But in hydrogen, one electron, one proton in protium. But in deuterium, one neutron is also there. Then proton and neutron, number of proton plus number of neutron, that is called mass number. Mass number. Okay, number of proton plus number of neutron, or number of actually electron or proton will be equal only. Then P plus N, that is called mass number. Then protium has one neutron and deuterium has two neutron. Hence, and tritium has, protium has no neutron, that's why 1H1, mass number is 1 only. Deuterium has one neutron, means 1 plus 1, 2, mass number is 2. In tritium, 2 neutron is there, that's why 1H3, mass number is 3. Okay. Then I have told you these isotopes differ from one another in respect of the presence of neutron. Ordinary hydrogen, protium, has no neutrons. Okay. Deuterium, also known as heavy hydrogen, has one, and tritium has two neutrons in the nucleus. Okay. And in 1934, one American scientist, its name was Harold Urey, got a Nobel Prize for separating hydrogen isotope of mass number 2, means deuterium, by physical method. The predominant form in protium, terrestrial hydrogen contains very less, I told you, 0.015%. Okay. Deuterium mostly in the form of, deuterium is found just like H2 we are writing H2. Then here deuterium is found both HD, D is also hydrogen, deuterium hydrogen isotope, and H, both will be mixed. Protium and deuterium both are hydrogen, just like you are writing H2, then both H is similar. But here HD means this thing, protium and deuterium both are together. Okay. Then this is found in less. If you will compare all three isotopes, then predominant form is protium. Terrestrial hydrogen contains 0.015. Already told you 0.015, 6% of deuterium. Okay, of deuterium, mostly in the form of HD. Deuterium is found less. The tritium concentration is about 1 atom per 10 to the power 18 atom of protium. If hydrogen, ordinary hydrogen is, suppose it is the 10 to the power 18, how big number is there, you can understand. 10 to the power 18. Then means tritium is found very less, 1 atom per 10 to the power 18 atoms of protium. Means if you will get 10 to the power 18 atoms of protium, then there 1 atom of tritium will be found. And out of 3 of these isotopes, only tritium is radioactive. Tritium is radioactive out of 3. Okay, and emits low energy beta particle. And its half-life period is 12.33 years, 12 years roughly. Okay, then I have told you isotopes. Then isotopes have, all 3 have seen that this atomic number is same. All 3 isotopes have atomic number same. Means number of proton, that is equal to number of electron, that is called atomic number. But they are differing in mass number. Mass number is equal to P plus N. P plus N. Number of proton plus number of neutron. That is called mass number. And atomic number is the number of proton, that is equal to number of electron. Then this I have told you about the isotopes of hydrogen. This what I discussed now, isotopes of hydrogen, many times in many examination question is asked from this isotopes. Since the isotopes have the same electronic configuration, they have almost the same chemical properties. The only difference is in their rate of reactivities. The rate of reactions, they will differ in rate of reaction, but they have same type of chemical properties, because chemical properties depends upon the atomic number, and atomic number is same, but they differ only in the rate of reactions, mainly due to their different enthalpy of bond dissociation. HH, ordinary HH, their bond dissociation energy is different, and H and D, DD you can write deuterium, DD, their bond enthalpy is different, and tritium, their bond energy is different. That's why they will differ in the rate of reaction. Okay. Now I am going to discuss preparation of dihydrogen. How hydrogen gas is prepared. Then you might be knowing also, but here other many reactions are there that now you should recall. If you are knowing, you should recall. If you are not knowing, then try to understand. First is that laboratory preparation. Laboratory preparation of dihydrogen means hydrogen gas. First, it is very easy. 2 methods are there. Generally, it is used in laboratory to prepare hydrogen gas. First, it is usually prepared by the reaction of granulated zinc, solid zinc, just like a small piece will be there, zinc, with dilute hydrochloric acid, HCl, means Zn plus 2HCl. It will form ZnCl2 plus H2, or Zn plus 2H, 2H plus. 2H plus you are writing because many acid is there, H2SO4 also, there hydrogen is there. In HCl also hydrogen is there. In HNO3 also H plus is there. That's why in a common way you can write in the term of hydrogen ion. hydrogen ion, because acidity is due to the H ion only. All acid will have H ion, general all acid, H2SO4, HNO3, H3PO4, then almost all acid. That's why H plus directly you can write. For the acid, H plus you can write. The Zn plus 2H plus, then it will form, actually Zn will lose the electron and hydrogen will take the electron. Then 2H is there, 2H plus means it requires 2 electron. Then 2 electron will be given by Zn, then Zn will become Zn2 plus, and this 2H plus now it become H2, hydrogen gas. Actually, generally it will form H2 Zn plus H2SO4 also. Zn plus H2SO4. Then SO4 you know that it has 2 negative charge. Then now Zn has 2 plus. Then it will form ZnSO4 and hydrogen 2H will form H2. And Zn has lost 2 electron, that is taken by hydrogen ion, 2 hydrogen ion. Now second lab method I am talking about, it can also be prepared by the reaction of zinc with alkali, aqueous alkali like NaOH, KOH, calcium hydroxide, etc. Then here Zn plus 2NaOH, Zn plus 2NaOH, then it will form 2NaOH is there, means 2 OH ion is there, then it will form ZnOH whole 2, not sodium zincate, it will form sodium zincate, okay, Na2ZnO2. Actually NaOH is also formed, but generally it will form this with aqueous alkali, it will form sodium zincate, Na2ZnO2, and hydrogen will be liberated, H2. Hydrogen will be liberated because in NaOH, H was there, then 2H is removed. Hydrogen has lost 2 electron, each one electron, and it formed H2. Okay, and another product is sodium zincate. Now commercial production of dihydrogen. Commercial, sometimes because hydrogen is very useful. Hydrogen is a very useful gas. That's why it is used commercially in a large quantity. In lab, all things are produced in less quantity, but commercially means you require in a large quantity, in more quantity. Then commercial production of dihydrogen, I am telling you. Here many, you can say, methods are there, then I am going to tell. Then first you can say electrolysis of acidified water. Acidified water means in water if you put little amount of acid, maybe HCl, maybe HNO3, maybe H2SO4, in little quantity, then water will become acidified. And if you will do electrolysis of water, last class I told you na, anode process, last class only. Anode process means reaction at anode, reaction at cathode, half cell, half oxidation and half reduction. That is actually called electrolysis. Then here you are doing electrolysis of water. Then you know that water is formed from the H2 and O2. Water is formed from H2 and O2. Hence, if you will H2O you will take and you will do hydrolysis, then it will give back H2 and O2. Hydrogen and oxygen it will give after electrolysis. Okay. Then 2H2O is reaction you can write, but here in electrolysis you require electrodes. I have already discussed. Electrodes are required. Then here you will require platinum electrodes. Both anode and cathode both will function as electrode only, anode and cathode. A platinum will function as anode and cathode. It has that type of property. Okay. Platinum will be have as anode as well as cathode. Then here both electrodes will be platinum, okay, made up of platinum. Then 2H2O, it will electrolyze and it will give 2H2 plus O2, means both gas it will give 2H2 plus O2. Okay, then now we are getting oxygen also, hydrogen also. Then it is produced in large quantity. A very useful electrolysis is very useful, electrolysis of water, because you are getting water, that is in a large quantity in ocean, in sea, water is there. Then there is no scarcity of water, and when water is there, then you can get in large scale, you can get hydrogen as well as oxygen, okay, by electrolysis. Now second, you can say method I am telling you, high purity. If you want very pure water, like a 99.95% pure dihydrogen, suppose you want hydrogen gas, pure hydrogen gas, then high purity hydrogen gas is obtained by electrolyzing warm aqueous barium hydroxide, BRITA, also called BRITA, barium hydroxide, BaOH2. Then electrolysis of barium hydroxide solution between nickel electrodes. Here you will take both anode, nickel function as anode as well as cathode. Okay, platinum also function same way, nickel also function same way, but you have to take as per your requirement. Then here for pure hydrogen, if you want pure 99.95%, because impurity will be also there in gas, but here 99.95% hydrogen, a pure hydrogen you will get by electrolysis of barium hydroxide solution between nickel electrodes. Okay. Now third method I am talking about, it is obtained as a byproduct. Byproduct, means extra. Main product, with the main product, some other product will be also there during the reaction. That is called byproduct. Then it is obtained as a byproduct in the manufacture of sodium hydroxide and chlorine. Okay, suppose when a sodium hydroxide is going to be produced or chlorine is going to be produced, then that time as a byproduct it is found. But this is also done by electrolysis. Okay, electrolysis of sodium hydroxide or electrolysis of chlorine. By the, if you will do, then that is here chlorine electrolysis you will do, then chlorine electrolysis of brine solution, KCl solution is called brine solution, KCl, not KCl, NaCl. NaCl solution is called brine solution, saturated solution. Okay, then because NaCl is dissolved in water, then only solution is formed. NaCl is solute and water is solvent. Then saturated solution of NaCl is called brine. Okay. Then if you will take the NaCl brine, electrolysis of brine solution, then NaCl is there. Cl is there, that's why you will get chlorine gas. And because you are doing this NaCl is dissolved in water, then H2O is also there. That's why H2 gas will also form. Okay. Then at anode, anode that is the positive charge, Anode have positive charge and cathode has negative charge. Then at anode, what will happen? Oxidation. Already told you, always at anode, loss of electron will be there. Anode, zinc you have seen, I told you, it lost electron, and copper got electron. But here you are doing electrolysis Cl, chloride ion, NaCl is there, na? Then NaCl, Cl minus. Then Cl has an electron, Cl 1 minus means 1 electron. Then 2 Cl, if you will take, then it will liberate 2 electron. It will give 2 electron, means oxidation. Hence 2 Cl will give Cl2 plus 2 electron at anode. Means this is the oxidation. Loss of electron is oxidation. Hence at anode 2 Cl minus, that will give Cl2 gas, chlorine gas plus 2 electron. Now at cathode what will happen? Then at cathode water will be there. Water 2H2O is there, that will take that 2 electron. This 2 electron liberated at anode will be taken by water at cathode, and what it will form? Then it will form H2 plus 2OH minus. Okay, this will form 2H2O plus 2E. Here reduction is going on. It have accepted that 2 electron. Then 2H2O, 4 hydrogen is there, 1 and 2 oxygen is there. 2H2O means 4 hydrogen, 2 oxygen. Then here that it will give hydrogen gas plus 2OH minus. 2OH minus. What they have taken electron, 2 electron. This H2O will break and hydrogen gas will be, you can say, removed from the 2H2O. 2H2O hydrogen gas, hydrogen H2 will be removed, displaced. Then it will form H2 gas. 4H is there, then 2H is used in forming the hydrogen gas, and 2 hydrogen, it came in the form of 2OH minus. 2OH minus means 2 minus is there, then due to this 2 electron. Okay, then here overall reaction, if you want to write overall reaction of this, then easily you can write what is, I told you, what is the left side, add it, what is the right side, add it, and that is the net cell reaction or net reaction, you can tell, net cell reaction or net reaction. Then here left side, what was the left? You have taken at anode chloride ion, 2 Cl minus, that was at anode, and at cathode it was 2H2O. Then in a balanced equation, net reaction you will write, because see one more thing here, 2 Cl minus you are writing, it means either K or Na will be there, because only ion will not exist, always will be KCl, NaCl. Then now you are writing in a neutral wave, molecular form. Then for the 2 Cl you can write 2 NaCl or 2 KCl, but whatever you are taking Na, right side and left side you have to write, then it will be cancelled. Then now you have to write in the right direction, in the this right hand left hand side you will write 2 Cl plus 2 Na. 2 Cl it was there and 2 Na left side, and water also you have to write. You have 2 Cl minus you are writing, then obviously some two positive charge should be there, either in the form of K plus or Na plus, but here you have taken brine, then Na only you have to take, Na. NaCl solution is called, saturated solution is called brine. Then 2 Na plus 2 Cl plus 2H2O at cathode, left side was 2H2O, then 3 term came left side, and right side, actually electron is cancelled, both sides, left side, right side, at anode and cathode. Then remaining things are extra, only 2 Na is there, then 2 Cl was there plus 2H2O was there left side, and product side it has given chlorine, it has given at oxidation, at anode it has given chlorine, right side product, then Cl2, and at cathode you got product H2 plus 2OH, 2OH minus. Then right side you will write net cell reaction. Right side you can write Cl2 plus H2 plus 2OH minus, and Na you have written left side, then Na right side also you have to write 2Na left side, 2Na right side. Then this is the balanced equation. Means a product you are getting Cl2 plus H2 plus 2Na, 2Na plus plus 2OH minus. Okay, it is very easy, just left side right side you add, and Na both side you add, because it was the brine solution. Then you will get reactant completely, you can write like this, 2Na plus 2Cl plus 2H2O, and product you can write Cl2 plus H2 plus 2Na plus 2OH minus. These three I have discussed commercial methods of commercial production of dihydrogen. And again I am telling you next, that is the reaction of steam is another method. Reaction of steam on hydrocarbon. Hydrocarbon means with carbon hydrogen should be there, or you can tell coke. Okay, only carbon, that is called coke. And hydrocarbon means carbon plus hydrogen, means compound of hydrogen and carbon. Then that is called hydrocarbon, like methane, CH4, sucrose, C12H20O11, that is sucrose, glucose, fructose. C6H12O6 is glucose, C12H22O11 is sucrose, sugar, what daily you are eating. Okay, then all are called carbohydrate, because carbon hydrogen is there and oxygen is also there. Okay, but here hydrocarbon you are using, oxygen should not be there. Then you can tell ethane, methane, CH4 is methane, C2H6 is ethane, C2H2 is acetylene, C2H4 is ethylene gas. Then compound of carbon and hydrogen is called hydrocarbon. Okay, then reaction of steam. Steam means boiling water, you know, that time water converts into the vapor, that is called steam. Steam is more dangerous than boiling water. Okay, they have more energy. If you will pass that steam on hydrocarbon at high temperature in the presence of catalyst, then that time you will get hydrogen. Okay, then actually in general way hydrocarbon formula is there, CnH2n plus 2, alkane. This is called alkane. In organic chemistry I will tell you, and here just know that alkane has a formula Cn, down n you can see, down n, H again 2n down plus 2, n is the number of carbon, Then suppose carbon is only 1, n is equal to 1, means carbon atom is only 1, then Cn means only C you can write, H2n plus 2, then n is equal to 1, then 2n plus 2 means 2 plus 2 4, it became CH4, methane gas. Like that way, if n is equal to 2, then according to the formula C2H6, because H into 2 plus 2, then 2 into 2 4 plus 2 6, C2H6. If like that way, if C is 3, then you will get C3H8, propane. Then like that way, this is the formula for hydrocarbon. Same formula is for, this is for alkane, this is called alkane. Same formula, same type of formula is there for alkene, ENE. ENE means double bond. In alkane, it will be single bond, carbon-carbon single bond. But in alkene, it will be double bond. And third type is there, third formula is also there, that is the alkyne, Y-N-E, and the end, alkyne. Then their triple bond will be there, triple bond. Then I will tell you for all the things in the appropriate place, means when we will start organic chemistry. Then here simple general reaction is there, Cn H2n plus 2 plus NH2O. NH2O, we don't know 1 mole, 2 mole, 3 mole. As per organic compound, as per hydrocarbon, N is water number of water molecules is required. As per you can say hydrocarbon, the hard type of hydrocarbon is there. Then in a general way, CnH2n plus 2 plus NH2O means hydrocarbon plus water molecules. When you will take suitable catalyst like nickel, platinum as according to the hydrocarbon. But temperature should be high. High means more than 1270 Kelvin. Okay. And generally nickel is used, nickel, Ni, as a catalyst. Then it will give you can say two product, because in the compound hydrocarbon only two are there, carbon and hydrogen. Then obviously when it will react with a steam is water, H2O. Then oxygen is there and hydrogen is also there, H2O. Then it gives two product. Hydrogen it will give and carbon monoxide it will give. Carbon gas obviously will give, carbon monoxide they will give. Then we will get NCO plus H2 gas will give, but how many molecules of H2 it will give? Then 2n plus 1. 2n plus 1. You don't know one molecule of H2 or 2 molecule of H2 or 3 molecule. You don't know. It depends upon the hydrocarbon, what type of hydrocarbon is there. But you will get 2n plus 1. In bracket you can write 2n plus 1 H2. If n is 1, then 2n plus 1 means 3H2. You will get 3H2. One example I am telling you. Suppose CH4, methane gas is there and it is reacting with H2O. Okay, simple molecule CH4 plus H2O. Both are gas, methane and water vapor. H2O means water vapor, steam. Okay, water, I told you, H2O may be ice also, solid, may be liquid also, may be vapor also in the form of a steam. Okay, then CH4 plus H2O, it gives two gas it will give, carbon monoxide and hydrogen gas. Means balanced equation you can write CH4 plus H2O, it gives CO plus 3H2. CO plus 3H2. This mixture of carbon monoxide and hydrogen gas is called water gas. Question is asked, what is the water gas? Then it is the mixture of carbon monoxide and hydrogen gas. The mixture of CO plus H2 is called water gas. As the mixture of carbon monoxide and H2 is used for the synthesis of methanol. Methanol is made from that time, these both are required. Mixture of CO and H2 means water gas is required to synthesize the methanol, and also number of hydrocarbons can be produced. That's why it is also called synthesis gas. Synthesis gas are in shortcut syn gas, SYNGAS. Syn means synthesis. Synthesis gas. Okay. Nowadays syn gas is produced from sewage. or from sawdust, SAW, sawdust, or from scrap wood, or newspapers. These are produced. Syngas. The process of producing syngas from coal is called coal gasification. Coal gasification. If you are producing syngas from the coal means carbon, only carbon, C, then solid, C plus H2O means steam it is there, it will form CO plus H2. This is also you can get it from the coal. The production of dihydrogen can be increased. If you want to increase the production of dihydrogen, then by reacting carbon monoxide of the syngas mixture with steam in the presence of iron chromate as catalyst. If syngas is there and you want to increase the dihydrogen, you want more. The production of dihydrogen can be increased by reacting carbon monoxide of syngas mixture with steam in the presence of iron chromate as catalyst. Then CO plus H2. CO is from water gas. CO plus H2 is there. Now that CO is going to be used. Again in that CO, H2O you are using. Then again it will produce hydrogen gas. CO2 is, then now CO will become CO2 and hydrogen gas automatically it will produce. Then now hydrogen quantity increased. Hydrogen quantity increased because CO was already there. And now again you pass the, especially in CO, H2O you have passed, steam. Then CO will convert to CO2 and again H2 will come out. Then quantity of hydrogen will increase. Okay. Then this process is called, water gas shift reaction, not water gas shift reaction, because more hydrogen you are getting and CO is converting into CO2. Here product is CO2 plus H2. Okay. Water gas is carbon monoxide, CO plus H2. Then carbon dioxide is removed by carbon dioxide is formed. Then carbon dioxide is removed by scrubbing with sodium arsenite. You can remove the carbon dioxide by use of sodium arsenite. Okay. And again here important things I am telling you. Presently 77% of industrial dihydrogen means hydrogen gas is produced from petrochemicals. Petrochemicals is organic compound. Okay, hydrocarbon. Then 77% of industrial hydrogen gas is produced by petrochemicals and 18%, 18% is produced from coal. What I told you, C plus H2O. And 4% from electrolysis of aqueous solution and 1% from other sources. Total 100%. 77 plus 18 plus 4 plus 1. 18 plus 4 plus 1, that is the 23. 23 plus 77, 100. Then now I have discussed about the preparation of hydrogen gas. Now today I am stopping only here. Next class I will discuss properties of hydrogen gas. Thank you.